So I think I'm really honored to start this seminar, this unit seminar, and I will maybe here give you another perspective. Monica was mentioned changing surroundings, changing power system, but also new conditions to go through. And I will here give you one example of how we are working at the moment and what we are trying to do to make sure we can develop our technical system in the Swedish Armed Forces to make sure that we are safest and efficient way we can to defend our country and our democracy. So, and I will always ask the question, how safe is safe? That is, I think, the $100 million question to answer one day. But until I get that answer, we have to keep on searching for it, I guess. So I will go through some methods we are using and how we think we can develop this and be more efficient now when we are growing a lot. So we can take the next slide. Thank you, Monica. Well, we have a main task here. Sorry for the Swedish, but I think you will understand what I'm trying to say anyhow. We do have an instruction, and we also had a military doctrine to focus on here and make sure what we are going to do, and that is to defend our country from armed attack, and also to make sure we have the territorial integrity intact and make sure that we have our border. We know who is inside the countries, who's outside the country, and what's happening and going on. And this is something we will have to do 24/7, and hopefully you do not notice it. That's our main goal. But we also have this task to prevent conflicts and, in the worst case, then a war, of course. And this is something we do every day, every second, every minute, 24/7, year round. So, but now we also have the new directions from our government here to increase our organization and our abilities to do this, because our surroundings are changing, the threats are changing, and we need to build up the defense again. And that's not only including the military defense, it's also including the civil defense. But to do this, we need to have methods. To do this, we need to focus on implementing and how do we grow without causing any unnecessary economical costs or safety costs. We do have finances. It's always a limitations, of course, and especially in our organization, it's a limitation because we are financed by our taxpayers, of course. That's the nature of a military industry, I guess, the military sector. And we all need to be very careful that we use our money in the best way we can. And we are also, by our nature, a high-risk organization. And we need to focus on that as well, because now we are also taking in recruits. People in our organization, some of them are not there by choice. It's a plikt, we call it in Sweden, which you need to be there. And we need to make sure to also maintain the trust that we can do our task and our main purpose to defend this country in the best possible way. So the civilians and the people of Sweden will trust us to do the best we can. That's a really, really important thing here when we are now growing, and we shall increase not only our abilities, but also our technical systems, of course, because to do the modern warfare is depending on lots of technical systems, complex technical systems, but also really, really very dangerous technical systems. So we can move on to the next slide. Thank you, Monica. So why do we work with risk then? I maybe answered that on the previous slide, but we have one here to say, just to summarize that, and that is to make sure we design and procure technical systems to provide us with the highest ability to defend and protect Sweden in the most cost-effective way. We're talking about different risks here. We're talking about safety risks and security risks. My presentation here will be most focusing on safety, but also the safety and the security risks here, they will always communicate. And I used to say, if we can't do our work and our task without killing ourselves or our environment or the other civilians, or causing too much harm, or it costs us too much, then we do not need someone who wants to hurt us. Then we hurt ourselves. So we need to start there and make sure that we are efficient enough and that we are really good at what we are doing. And that is also something to remember here, because everyone who wants us to hurt us, or the security party, they will use our flaws and maybe our weaknesses in the safety zone to get to us. So it's really a communicating areas here, both safety and security. So they need to go hand in hand. But now I will focus on the yellow ones here for the most in my presentation. And why do we do this then? Well, we can never ever have an imagination that will be better than the reality. So we need to do this to make sure how we can prioritize what we need, our dependencies, and how we can make sure that we still can fulfill our task when reality comes and knocks on our doors during really, really harsh times. The worst scenario here we're talking about is an armed attack on our country. And maybe you can imagine how hard that can be. So we can move on. So therefore, I have just taken a really principal example. This is just not how it looks in reality, but just the principle of what we are trying to have a safety management system in our organization to make sure that we can keep track on the risks and make improvements all the time, and also how to be better on how to break down requirements on those who we are depending on, and also those who are depending on us, to make sure that we can do our task all the time 24/7. And I will take the command and control system as an example, and be more specific, the Air Force command and control. So we can move on. But first of all, how can we decide what is enough then? This is hard, but I will just want to say that we need to start to focus on some sort of a language, because this is my experience from different organizations. We want to take risk-based decisions like safety management and know what's good enough. But to do that, we need to have the safety management, the safety assessment, of course, to make sure what kind of different solutions do we have in front of us, to make sure that we can take the best decision here, to have like the consequences we can live with, but gain some positive aspects of that decision as well. But to do that, we need to have the risk analysis or safety analysis, which you are really familiar, especially from the nuclear industries, to do so. But sometimes these three parts are working in islands, and they are really not talking the same questions, or the same language here and responding. So this can be really hard. So I've been focusing on now to make sure that we can have a risk language, a safety language, so we easily can understand each other when we are degrading a function or something is getting more risky. And do we have a hazard here or potential hazard here? How can we stop it before it happens? And to do that and to recognize what's important for us, we need to focus on that we have an organization and we have methods to do our task, and we're going to use the technology to make sure that we will complete what we are supposed to do. So, and here is the important thing, to have this communication between these three areas, because what will methods and organization do when the technology or technical system will fail us? And that's the question through all my presentation. What will we do when the technology is not there anymore? So we can take the next slide. So the safety concept here, the language, a common language, will go through the technology aspects here, because why do we need to focus on the technology or technical systems here? Because that's something really important for us, and they are really complex, and we can't design and procure a system that will be 100% safe. And it's really hard to procure a technical system that will be during a stressed situation. So we need to be proactive here. And when a situation will be escalating, or we will go into like the worst scenario, like an armed attack, then we need to use what we already have. So this is a way to be proactive. We can work with methods and organization quite more flexible than we can do with the technology. And it also takes really long time to learn how to use the technology we are using. So, and it's really complex functions I will soon talk more about. And this is also important to understand, that it's the time difference here and the complexity in the technology and technical system that will be why this is the focus here when it comes to safety management. I think you are really aware of this when it comes to like designing and analyze the electrical system and nuclear power plants, of course, but it's the same for us as well. And we need to also make sure that we talk easier to each other when it comes from the strategic end, where we're designing and constructing and having the safety fundamentals, when it comes to the operational as well, so we get the feedback in a better way, in an easy way, so we can talk to each other. And also we need to identify, and why we do this, to complex dependencies, especially when it comes to technical systems we are depending on when it comes to different sectors in the like the energy sector and the navigation for our airspace and so on. When it comes to those parts, we need to be more specific of what we need and how we are working together. So this is also to show the complex dependencies between technical system in a safety function, which we also will be using during highly complex scenarios. So that's why we are choosing to talk about more the state-based approach. And I am really aware that Matthias Karlsson and also Mr. Kevin Pepper and Singh can elaborate on this a lot more, maybe in the next session. But that's why, because we can't foresee any scenario here, because that's a part of the warfare. We call it in Swedish krigslist. So we need to just focus on the states to make sure we have plan A, B, C, D, and so on and forth, and make sure we have a plan to take us back to the normal state. So what is then a safety functions? I think we will go into that on the next slide. So you can switch now, Monica. Almost next slide. First of all, we also need to keep track on requirements for different perspectives. And we need to be looking at the holistic view of what we are doing. And we need to go back to the fundamentals of why we exist here, and that's the ability we're talking about. We have military abilities here we need to fulfill. And one ability here is like the command and control for the Air Force. That's one, a military ability. And to do so, we have different functions to make sure. And here's where we have our safety functions in this level, and they will be there, and they are built up by technical systems, which in parts also are built up by components. And we need to see this chain and make sure that we evaluate risks in every step. Because if we it's really easy to just focus on the components of the technical system sometimes, but that's when we risk to be like, sub-optimizing our risk-based approach, because we will miss all the overall risk to not be able to have the military ability. And that will always be the first thing we're going to talk about and what we're going to strive for, to maintain the ability. And not, we can sacrifice a component sometimes, but if that's really crucial for the ability to maintain and go on, then we need to focus on that as well. But the whole the holistic approach is really, really important here to make sure we get where we want to go, so to say. So we can move on, but just have this picture in your mind where we are and where I'm talking about, and why this is really important to structure this in a certain way to make sure we can evaluate risks during our daily job, so to say. And to do this safety function, here is just an example for what's important for us when it comes to the C2 Air Force. We have communication systems, we have the radio, we have telecom, and we have sensor in form of radars and so on. And then we have the command and control center in itself. And they need to have backup plans in the defense in depth concepts, which you call it in the nuclear industry. And I think you call it the system states in the energy sector, electricity sector. But also we can identify here that all these safety functions, they are also depending on the auxiliary functions that's important to safety as well. To this, the transmission when it comes to information, and it's also the power supply to make sure that they will all function, and they are connecting all the other safety functions together. So they are really important, even if you say that they are just supportive function or auxiliary functions. They are necessary for us to maintain our ability here. So when it comes to safety in the command and control, to know where we are and to communicate risks and different information during operations and even joint operation is really important for us. Then we can make risk-based approach, and we can change and be flexible. And that's why we need to have track on those systems providing us with this kind of functions and, in the end, the ability. So And they also need to have the defense in depth, and we need to have a plan A, B, C, D, and make sure that we know how to make it back to the green field. So we can move on. So what is it then? This is just me giving a really, really simple example of how, when we were focusing on the radio, for example, the safety function radio, it's important for us to communicate with all the air, with all the people up in the air, of course, and to make sure that we have an airspace that is safe, because here we are depending on the air navigation service provided by LIFECYCLE in Sweden. And here's a dependency from them when it comes to the radio and the sensor, because we are using technology which is common for us as well. And also, if you look at this picture, when we are describing the function here, what's depending on all the technical system in it, it's not all technical system, as you can see, but it's just an example for you. We have dependency for what we call the A here. It's the national grid, the power from what do you call it, outside. The A power, we call it. The B power is our reserves, our own reserves, and C power is uninterruptible power supply as well. And then we have ventilations. And then you can see that the radio, it's supposed to be, we have lots of radio stations out there in the country to make sure that they will be a capacity that will be enough for us. They're connected to some sort of an IP system or radio link or whatever it could be, to make sure we transfer the power, transfer the information from the radio in through several nodes into the command and control center, which you can see in the middle of the picture here. And this is what we are depending on when we have to look at this. And to just make sure that we have a defense in depth in the radio, it can look like above, as you can see in the green field, we have like the N-1 criteria here. We can lose one radio station without losing any capacity at all. But that's just a hint for us that we are degrading the function here. And then we have different way of solving that. We have mobile solutions, and we have also procedures and so on, and how we then are working and taking high risk or separating the airspace from the civilians and so on, to make sure that we are taking care of increasing risks when the technology is failing us more and more. And how will the organization cope with that? Because this is something really important, why we want to work with this dynamic risk approach and the state-based approach, because we will never go home. We could never quit. That's just how it is to work in the Swedish Armed Forces. And if you go back to your own organization representing nuclear safety or the electricity system, you will never go home either, I guess, because this is a common thing for all the important safety functions in the society, to say so, those who is important for a functional society, like the electricity system, for example. You can never go home. So this is why we need to have these different plans, and also a backup plan how to restore it and go back to the green all the time. It can't be every function in the Swedish Armed Forces, of course, but it needs to be the baseline, what's most important for us. And so we can continue do our task, because that's really important for everyone in this country, that we can continue do what we're supposed to do. To have these given criteria instead of probabilistic sort of how often do we leave the green field and so on, this will also give us the importance for risk-based decisions, because as I said, we will never quit. We will just take higher and higher risks, unfortunately. That's why we really want to be in the green field. And this is also a tool to identify requirements and dependency. Just look at the picture, and we can only from this safety function identify how, and this military ability, identify some dependency to this certain sectors, like the airspace and the air navigation providers, and also for the electricity system, but also when it comes to the communication and telecom industry and sector as well. Just here we have dependencies to keep our margin and to keep our resilience, to make sure that we can continue to do what's most important. And the states also describe how we can perform our task and what risk we take. As I say, limitation in operations if the risk is too high, or we can take decisions that we will take this risk because the situation is also there, so we need to continue. This is also requirements for the maintenance and identify improvements. And that's really important that we can, as I said, speak to the operational organizations and make sure we have the feedback loop. We can continue to the next slide. And here is the life cycle of a technical system, feedback from the operational organization. It's really, really important to learn all the time and make sure how often do we leave the green field, so to say, and how is it going operational perspective, but also when new requirements come from, like the government, or the new needs for our different ability in the military, we need to make sure that how do we build this and how do we make sure that the operation and maintenance space will continue to work, because if they can't do their job, then there's nothing more left, I would say. Then we have failed in the strategic and planning session, so to say, when we do the concepts and development. So it's really important to have the feedback loop working to make sure that we are working with the risks we have and we are aware of them, and make sure the incident reports, but also when we see something, a great example, not only the incidents. I would say it's more or less more important to make sure what is good, what's working, something surprising us, working better than we thought. And that's a really good lesson to have. But then we need this to make sure we have this language, we understand each other better, and creating this loop being more and more easily going, because we will grow so fast now. So we need to have really, really easy communication and this management tool, so to say, to understand each other, because we are quite a large organization. And we also, as you can understand, have this connection to all the different sectors in the civil defense as well to talk to. So it's good for us if we can do this in a better way than we have done when we were smaller. We need to be more efficient, so to say. So we can move on then. I also talked a lot about these dependencies and the complexity, I would say, because this is quite large systems to understand. And they're really weird picture up in the right corner here. It's supposed to be Sweden divided into some hypothetical areas as well. But just to make sure that we have the right, we know what to do in the different areas and how to make sure that we are working with all the society in those areas, that we can make sure we have the resilience and the margin to do our job as well. Because we know that we can see here where we have single point of failures and common dependencies on technical designs, and they are really specific when you look at the functions here and not only looking at the technical system and components. And this is good because then we can be more specific of what we need and why we need it, and also we can have the feedback loop back from the civil defense as well. It's the common dependencies between, just in this example, you have seen the power supply, the air navigation service, and information and communication systems outside the Swedish Armed Forces here. And we know as a fact, it doesn't matter if you design a nuclear power plant or another really safety, high risk sort of industry or function in the society. The auxiliary function as communication system and power systems are always a risk for single point of failure if you do not address this properly. And different aspects of requirement, depending which system we're talking about here, is also something we need to take into, because when it comes to communication system, Swedish Armed Forces are the one who's providing all the society sectors in the societies with tools to make sure we can share information in sometimes. And like when it comes to the national power supply, the A power, so to say, here we are totally depending on the energy sector or electricity sector to make sure that they can fulfill the requirements from us in the civil defense as well, because here we need them to make sure we have the resilience and the margins so we can withstand and withhold the worst dimensioning scenario we can think about, and what we are obligated to make sure that we can meet. And that's an armed attack again. So we need to focus on that, and that's why we also need to have the defense in that with them, so we can talk to the other sectors and make sure that we are more and more specific of the requirements of what we need and how we're going to do this when the sun is not shining and everyone is not friends with each other. So this is also the complexity in how to put requirements. Sometimes we are the one who's putting requirements on someone else, and sometimes this other sectors is putting requirements on us. And this is also making this a little bit more complex than it maybe is, just because of the role and organization in the society. So we can move on. So when are we supposed to be safe? I have mentioned that a few times already, but this is just a summary. We need to take care to look into the worst scenario, of course. Can we handle that? Then we can handle a lot more as well, even if it's not really an armed attack. We can't start to design or procure technical system when we shall do our main task and defend our country. We really need to be proactive here. So that's why we need to work, especially with the technical system. And still, our regulation about safety for civilians, our environment, and be cost effective will still be valid during a war scenario. We can't have a bad day at work and we can never go home. And our soldiers should be comfortable with the technology we provide. They have enough risk to handle during their job. They have a really high risk job here. So we need to do everything we can to make sure that they are taking less and less risks, especially when it comes to the technical that will be there to serve them. And they also need to understand what we are going to do when the technology fails us. And that will be something they need to understand before we start an operation, so to say. And once again, we will never go home. We will never stop doing what we need to do, but how good and effective will we be outside normal state then? It's also how do we want to do this? We do not want to take high risks because we can't afford it. And also, once again, the resilience and safety risks, I put safety risks here because if we have flaws in our systems and if we have weaknesses, that will be a part of the warfare. So you can't really separate the security and safety here, because if we're really good at our jobs and make sure that we do not have flaws, then this is the best way of prevent an attack from the outside as well, the best way to prevent a security risk in the most common way. And I will say this is also valid for the civil defense and the other sectors. We have seen how in the Ukraine, for example, when it comes to electricity system, where you have an attack and in the cyber domain, and they were hacked into the electricity system. I think it was year 2015. And this is a typical flaw they use to go into the system and make harm. And this is really important to make sure that we have track of our weaknesses so we can prevent this from happening. And so all these dependencies is also really good to have acknowledged, so we will have track of our weaknesses, of course. We can move on to the end. So to do our military service, we are depending on both the civil and military defense, of course. This was just one example. You can replace Air Force with the Marines and the Army as well. And then we have lots of areas where we need to interact with the society, so to say. And it's a highly complex system where understanding of dependencies and technical limitation and possibility are crucial. And it's crucial to have that in a proactive way, so we know what we have and how to use it in the best way when we need it the most. The fundamental robustness and resilience are determined when we design a system, not when it's in operation. So when we are redesigning something, we need to take this into as a requirement. And this is also when it comes to the civil defense as well. And it's really hard when we have designed and procured and implement a technical system, we have to live with it for a really, really long time. And all the limitations it has will we live with and have to handle during that time. So it's really important to make sure we design good system, make good choices, so to say. We know that all sectors in the civil defense have obligations to fulfill requirements from Swedish Armed Forces. We are at the beginning of building up the total defense again. It is time to assess needs and requirements on how to implement and make sure we have the ability to fulfill our obligations during difficult times. It is really important now. We have started all this planning and process and so on. Now we have to soon start to be more and more specific of the requirements and how to do this and the implementation of it. And as the last line here, we will never stop and we will never quit. And a question I ask myself, and I want to ask you as well, have we done everything in our power to make sure our operational personnel or soldiers or whatever have the technology and qualification to be heroes when we really need them to be our heroes? Do they have the ability to do their job when we really, really need them? So to the last question, do you have a plan B? Thank you very much. So then you can click to the last slide, Monica.
Oh, did you have a last slide?
Yeah, I had the last slide actually. That was not the one. It was just some reading. There. If you want to read more for your reading pleasure or whatever you say, we do have some handbooks, and we have a network for system safety, and we also have Handlingskraft and Motståndskraft. Those are all in Swedish. But if you want to read more about this and where we're going, this is just a tips from me. Thank you very much.
Thank you, Maja. And are there any very quick questions to Maja? Otherwise, I have one, and that is, I mean, you have a lot of experience both from the Swedish regulator and from the Statnät. Do you have any good ideas for the nuclear industry that we could implement, given what you have learned now in the new position with the Swedish Armed Forces?
Well, yeah, what kind of how will you fulfill your task during those really harsh scenarios we are talking about, and how aware are you of the connections here, and how dependent we are on each other, and maybe not dependent as well, but how can we make that into the original design and overall day-to-day work in the energy sectors overall, I would say, because it's a mindset to talk about resilience and how to make sure that the electricity sector and the nuclear power plants can still be running or not running or whatever, just to make sure that we have clear to us what we are going to do and what's going to happen. Because that's some sort of that will affect the energy system and also the surrounding and the conditions on how do we take risks when the sun is not up and everybody is not friends with each other. It's a hard scenarios to look into, but I think we need to start thinking about that more and more. Was that the answer?
Yes, thank you. And then I have another question. If you look at within Gino, we discussed a lot about this new normal situation where a lot of the grid parameters will change. Is this something that is also discussed in Swedish Armed Forces, that your A power will sort of have a different quality perhaps in the future?
Yes, the A power is one of our dimensioning criteria for how to design and make sure that our reserves are enough, and where should it be enough, and so on, and where in the country do we need them the most, and so on. So that's really a close one, and it's crucial for the design work here to make sure that we have enough reserves, and that's depending on how good and robust and resilient a power we have to use during those situations. So yes, and we did talk a lot about this with the energy agency in Sweden, Energimyndigheten. We had actually a meeting with them just a few days ago and talk about the risk preparedness plan and how to work through an electricity crisis, and how they can support us in our job, and how the society will react during those kind of crises, and how do we prioritize functions during those times, and so on. So yes, we are talking about that, and it's something we need to look into more as well.